morning, my dear students. Welcome back to our channel Chemistry with RK. Hope you're all doing well. So, in this video, I have come up with a beautiful organic conversion in which we have a dialcohol compound in which we have one primary alcoholic group and one is secondary alcoholic group. And then that is reacted with chromic oxide, which is a strong oxidizing agent, which is taken in excess, which indicates that we need to oxidize both primary alcohol and also secondary alcohol. We know that primary alcohol gets oxidized to aldehydes and secondary alcohol gets oxidized to ketones, and then that gives a product P, and then that further reacts with ethylene glycol, which is actually used for a protection of functional groups, especially the carbonyl compounds, either aldehydes or ketones. So in the product P, we can see both the aldehydic group and then ketonic group. So that is going to protect aldehyde group, since we know that aldehydes undergo nucleophilic addition reaction with more rate compared to ketones, and then that is going to give a compound Q, and then that further reacts with Grignard reagent followed by acid hydrolysis to give R, and that final product is undergoing reduction by using sodium borohydride, which gives S, and we need to know the weight of that particular compound S in zero point 0.1 moles of that. So let's start solving the question. So we have a di-alcohol compound, that is, one is primary alcoholic group, another one is secondary alcoholic group. And when we react this with chromic oxide, as I told you, so this is a strong oxidizing agent. It converts both primary alcohols to aldehydes and then secondary alcohols to ketones. Yeah, this is our first product. And then next we are supposed to react this with ethylene glycol. ethylene glycol से react करना है. So what happens here is this particular ethylene glycol is going to protect our aldehyde group. Okay, so what type of product we are going to get is, so we have a ketonic group and then we have an aldehyde group, right? So let me just draw the same structure here according to our convenience. So we have a ethylene glycol. So this particular water is going to go out and then the final product in this particular step is we are going to get a cyclic ketal. Yes. So this is our product. And then in the next step, what we are doing is we are reacting it with the Grignard reagent. So now only our ketone group is available for the nucleophilic attack, right? So what happens in this is CH3MgX or CH3MgI they have given. So we know that this is going to attack here and then nucleophile O minus is going to form. And then what we are going to get here is we are going to get a methyl here and a O minus group here. Okay, so there is a O minus and then here the cyclic ketal group is still there. Okay, and now when we are reacting or when we are just adding water to this, what we are going to observe is anyway this O minus will attack by H plus of water, and then similarly this is going to regain back, our aldehyde is going to regain. So in this step we are going to deprotect our ketal actually. So we are going to remove our ketal and then we are going to get back our aldehyde group. So that's how we protect the aldehyde functional group actually. Hope you understood. So we have a methyl, we have a alcohol here. So we have aldehyde back. Hope it is clear. Yes. And then that particular compound, that aldehyde compound, so we have CH3 and OH. We have a aldehyde that is going to react with sodium borohydride. Now we know this is a reducing agent and it reduces aldehyde to primary alcohol. So what is our final product? Methyl and then OH, and then this is going to be our primary alcoholic group. Okay, so this is our final compound S. So इसका ग्राम molecular weight एक बार find out करेंगे. So we have totally of 1, 2, 3, 4, 5, 6, 7 carbons. Just observe, we have 3 hydrogens here. We have 2 hydrogens, we have 2 hydrogens, 2, and then CH, and then again CH2. So just check, here we have only carbon. So we have totally of 7 carbons, and then hydrogens how many? 5, 7, 9, 10, 11, 12, 13, 14 hydrogens. We have 14 hydrogens, and then 2 oxygens. Please try to find out the molecular weight. So 12 into 7 for carbon, plus 14 into 1 for hydrogen, plus 16 into 2 for oxygen. So 12 sevens are 60, 72, 84 plus 14 plus 32. So all together we are going to get 130 grams actually. So 1 mole will have 130 grams, 130 grams, but they are asking for 0.1 mole only. In the question they are asking only for 0.1 moles. So which means it is going to be 13 grams. So answer for this question, yes, is going to be 13 grams. Very important. Hope you enjoyed this conversion. Hope you like this video. I'll come up with another question or the next concept. Keep watching Chemistry with AK. Thank you for